Our first presentation is titled Observations about Sunflower Production. Dr. Hans Kandel, he was an extension agronomist from North Dakota State University. Dr. Kandel is based at the Fargo campus. He received his MSc from the University of Reading, England, and his PhD from NDSU. Kandel has developed innovative extension programs for producers in Northwest Minnesota, North Dakota, and Manitoba that blend not only agronomy, but also crop, soil science, and economics. Hans' extension program also addresses the needs of broadleaf crops, which include sunflowers, crop management, and crop covers. He also conducts applied research with various broadleaf crops. Hans is a member of the National Sunflower Association Research Committee and has been on the National Sunflower the National Sunflower Survey Coordinator. So please help me welcome Hans to the podium today.
Well, thank you so much. We'll get the presentation going here. I'm talking about sunflowers today, and during this presentation, the last couple of days, we have been talking about the importance about field selection, about some of the things like water management, like drainage. One of the interesting things, of course, about sunflower is that it is actually considered to be one of the crops that is a bit more drought tolerant, but it is actually the way that it can take water out of the soil profile. So one of the things that we kind of need to consider is, in the crop rotation, where does it fit? So we should always avoid growing the same crop in the same field. So in this graph, we are comparing the sunflower grown after wheat, after pinto bean, potato, and sunflower. So comparing the sunflower after sunflower, you would definitely give up some yield, but also you would encourage some of the pathogens to increase. So that is a no-no. So we typically are looking at growing sunflower after a small grain crop or after corn or after soybeans. So those are the main crops that we place sunflower after. So as I mentioned, comparing to some of the other crops, sunflower has one of the more deeper root systems and is able to obtain some of the moisture and nutrients from a larger depth. We have been visiting previously about some of the salinity issues. So this is kind of reminding us about the salinity in Manitoba, that it is a true issue. So I'm going to compare the kind of a couple of crops here quickly to show where sunflower fits in its tolerance to salinity. So here is an electrical conductivity map with salinity issues on the bottom and the relative sunflower yield. So we discussed earlier in the program that an electrical conductivity of that 1 would give you still crop production, but as you can see, you already lose some yield. But I'm comparing it here, for instance, with dry bean. And now I'm looking at a EC of 2 for sunflowers, which is indicated on the left of the graph, which would give you about 80% of the yield. But if you look at dry beans, you would get only 40% of the yield. So relatively speaking, sunflower would be a little bit more tolerant to saline conditions than, for instance, dry bean or soybean. So we talked about available water as the driving issue for crop production. So I'm just kind of walking you through a simple kind of quick calculation. So typically we're thinking about 1 inch of water will give you about 140 pounds of yield per acre. However, the first 5 inches of water are required just for the plant growth and to get to the point of seed production. So in Winnipeg, May to September last year, we had about 10 inches of rain. If we just assume that we had about 5 inches of water at planting in the soil profile, plus the 10 inches of rain, would give you about 15 inches of available water. 5 then for the vegetative growth, so 10 for the seed production. So you multiply the 140 times the 10, gives you an estimate of a yield of 1,400 pounds per acre. currently in North Dakota, the forecast is about 1,600 pounds. So you can see, this is a rough calculation, but it gives you an idea. So in other words, if you are in a drier area, but you have enough stored moisture, you can still obtain very good yields. And in North Dakota, we have heard some very good yields, even under drought conditions here, if there was water in the profile. So looking at kind of the longer trend for sunflower yields in North Dakota, I'm going from 1970 to 2020, and we put it all on a graph, and then we can get a regression analysis. And I'm looking here at kind of the analysis, looking at that number, which indicates that there was an increase in yield potential on the farm of about 12 pounds per acre. Now that increase is of course due to an increase in genetics, but also in an increase in management. So looking at sunflower, we basically have two types of sunflower. And I would say Manitoba probably has the non-oil type as the most dominant, but there is also the oil type available. And then we have different oil types, the high oleic or the medium oleic. Then we have a number of herbicide traits that can be selected for both in the non-oil type as well as in the oil type sunflower. So if we look at the most common traits available right now, it is the Clearfield or the Express sunflower. The one thing, of course, with any crop where we have more traits available, there are things that can go wrong. So one time when we were doing our sunflower survey, we came across this sunflower field, and there was this big band of sunflower that was all not doing very well. And the story behind this field was that the hired hand had grabbed a bag of non-express sunflower seed and dumped it in the planter. And here you can see, if you come with the express on a non-tolerant hybrid, you can do quite a bit of damage on those. So on the hybrid selection, of course, we are looking at yield potential. We're looking at oil content or at the size of the seed for non-oil type, and test weight is important. We also need to look at the disease resistance and the insects and the maturity of the particular hybrids that are available. Now, in North Dakota, we test quite a few hybrids. Those can be found on our website. The easiest is to Google NDSU variety trials, and you will get some of sunflower information. So I'm just kind of showing you some of the data here from last year. I just got the data in for 2021, but this gives you an idea that we tested quite a few of oil sunflower hybrids. We're always looking at hybrids that are yielding above average. So you need to select something that can do well in the region. So selection of hybrids is the number one thing, the first decision that farmers need to make. I looked at some Manitoba data from last year for a non-oil type, and here you can see that there are a number of non-oil type hybrids available. In this case, the two were not significantly different in their yield. So the next part I want to kind of discuss is a few of the management practices. So when we are talking about the two different types, there is going to be a difference in the number of plants that we want to be established in the field, because for the non-oil, we want to have fewer plants so that the heads are bigger and that the seeds in the heads are also bigger. So that is why the oil types, we are looking somewhere in the 20,000 plants per acre, whereas in the confection, we're looking more in the 17,000 range. Now, there are also two types of planting available. We can go to row planting, or we can do solid seeding. With solid seeded, when it is very narrow row spacing, we could go in a bit of a higher plant population. So then there are a couple of interesting things about the population, because the plant is so elastic that if you have drier ground, you're probably better off with a little bit lower population. And then the plant can develop its head size depending on the available moisture during the season. Under higher water availability, for instance, with irrigation, we can have a bit of a higher population. Then as the plant is developing and the bud starts to open up and the flower starts to develop, you will see that it follows the sun. But once the head is really flowering and is established, it will face to the east. So if you look at the direction of the rows, if you have a north-south row, then the head will be facing to the east. So the head will be hanging in between the rows, and there is a little bit less chance that the heads will be rubbing each other and you will lose less of the seeds, and it is a little bit less easy for the birds to hop from one head to the next to eat the seeds. So then when we are looking at one of the major production factors that we can influence, then that is the fertility. We've always to be careful that we don't put too much nitrogen with the seed. So I'm going to show you a couple of slides just to show you how at NDSU a tool was developed to kind of get a good estimate on a nitrogen application. So a lot of testing was done, and here it was only looking at the application rates. So on the bottom of this graph, you see the application rate from 50, 100, 150 pounds per acre. And all the black dots itself are the results of the many trials. And then there is in the center kind of the graph is the kind of the trend line. However, if we are looking not only at the amount given, but we also include the soil test, now we get the N rate plus the soil test. And here is a graph that kind of differentiates a little bit better how the crops responds. As you can see, there is a lot of noise in this. This indicates that depending on the location, the application rate can be different, but there is not always a kind of a clear-cut rate. But if you then correct it over all those environments and you correct it to the same yield level, now we are getting more of a yield curve. And out of this yield curve, my colleague, Dr. Franzen, developed a tool to kind of come with some recommendations. So this is normalized with known N, meaning that is the application as well as the soil N. So what he did is he kind of looked at the sunflower seed, the price that you get at the elevator on the left, and it is in US dollars, and then the cost per pound for N. It is just giving you an idea how this table works. So currently we have a pretty good price for sunflower, but also the cost of the nitrogen, of course, is high. So we kind of look at this cross between the 2 points. And if you look at the table, you see that if the price of the fertilizer is higher, economically speaking, we should probably reduce the yield or the application rate of N a little bit. Now, within that program, there is also a way to add some of the nitrogen that is available. So available can be measured, but it can also be guesstimated. So this is just new data from AgVice looking at Manitoba and North Dakota, looking at the residual nitrate after soybeans. So this shows like in the 32, 33 pounds of N after soybeans. So the tool, it is a little bit of a busy slide, but you can find this information yourself. But you can see there are many places where we can enter data. So some of the things that we can enter on the left is the sunflower price, the nitrogen cost, the organic matter of the soil, then the soil nitrate test level. And then on the right of the columns, you can see that there are questions of which zone are you in. So if you look in Manitoba, you could either go for the eastern zone or for the Langdon area. If you just live north of the border, then there is something about tillage, a question, and selection of the previous crop. So that in the bottom, you will get there the recommendation. So if the total recommendation would be for total amount of 150, but because there was some nitrogen still in the soil from the nitrogen testing, it will give you an amount based there on both the nitrogen cost and the sunflower price. You can play with this and kind of get some ideas of what you might want to apply. Well, we talked about the application, but also there is, of course, in kind of after the season, amount of nitrogen that can be left in the soil. So again, this is up-to-date information from 2021 for both Manitoba and North Dakota. And it shows here that the amount of nitrate in the two feet was about 34 pounds in 2021. So the next thing I'm going to discuss is a bit about row spacing. So a lot of growers are using a row spacing of 30 inches. That's very common in North Dakota. But if you are going with narrow row spacing, we have found that you can increase your yields. However, you need to be set up for it. So, but if you go with very narrow, which is the solid seeded, you're probably giving up a little bit yield again because it is not well distributed. So here you can see the second graph going from 30 inch to 15 inch. We see a statistically increase in yield. So we can increase yields by better utilization of the surface area by distributing the plants properly. Planting in Carrington, which is central North Dakota, studies have been done starting from the 1st of May planting all the way into the 2nd to 3rd week in June. And really it shows there that center of the graph, the 20th of May till the end of May is optimum for Carrington. It might be a few more days later than in Carrington in Manitoba, but it gives you an idea that there is a time when you can plant a little bit too early, and sunflower is a warmer season crop. But if you plant too late, there is sometimes not enough time on the clock. So one of the things we're going to talk about is that seed establishment. And of course, it depends a little bit on the type of equipment that you have, how well you will be able to distribute the seed. So we know that it is important that we need to adjust the planters. And specifically, if you think about a sunflower, which is only 20,000 seeds per acre, or plants that we want, we have to drop a few more seeds compared to the canola or wheat, where we have a very high population. So it is very important. So also the different seed lots have different seed sizes. So you need to make sure that the planter is well adjusted. So crop establishment, of course, is the important part, and that has to do with the moisture. We can have high intensity rain. We can have too dry of a soil, quickly drying. We can have insects in the soil that may eat the soil. Sometimes we have even birds that come and pick the seeds out of the soil. So poor seed quality is another factor. So I talked about the solid seeded and very narrow rows. It looks a little messy. On the right of the graph, you see the row spacing. So one of the things with solid seeded, you can see that there is sometimes, it is even hard to see where the rows actually are. But if you go to the 30-inch row spacing, if we are missing a plant, we typically also miss then a head, and the heads can compensate somewhat, but there needs to be an equal distance to get maximum yield. So if we're talking about seeding rate, on the left of this graph, you see plants per acre going from 7,000 all the way to 25,000. We're looking at the yield, and we see that there's an increase in yield, and it kind of tapers off at that 20,000 plus. It starts to kind of even out. Then if we actually look at the head diameter, what you can expect is if you have fewer plants, you will have bigger heads. But there is also something at the harvest time when we are thinking about the head moisture. If we have very large heads, it will take a long time for those heads to dry down. So we have to get the sweet spots where we get kind of equal size of heads, that we have dry down that is reasonable, uniform. We talk a lot about conservation of soil, but also about moisture conservation. So if we go from the more conventional till, we see that there is a lot of increased interest in strip till or no till, and of course with reduced tillage we conserve the soil better, but most of all we conserve moisture, which oftentimes sunflower grown in the drier area will respond very well to that extra moisture. So also with more cover, we hopefully can increase organic matter over time and increase the biological life and may improve the soil structure. So another factor that is kind of a little bit newer thought in the region is that we're talking a lot more about cover crops, including those in the various farming systems. Oftentimes we think about planting cover crops after a crop like wheat or canola, but you could technically also seed cover into a standing crop. So I'm just showing you a few of the pieces of equipment that have been used. The left two were on a project a couple of years ago from farmers that were interseeding into sunflowers. So it can be done. And here's a picture of where we seeded hairy vets into standing sunflower at the V4 stage. So hairy vets is very competitive. So if you plant it too early, there might be a little bit too much competition. So black lentil, another crop that was interseeded into sunflower. So I'm just going to kind of talk here a little bit about the principle. So in this graph, the bottom is the days after planting. And on the right-hand side, you see the crop height. So the yellow graph here is the crop height. So as the crop is planted, it grows slowly, then all of a sudden it has an accelerated growth. And then once the bloom comes out, the height is determined. So that is just kind of at about 80 days after planting. However, if we look at the next part of the graph on the left, that is the percent light that reaches the soil surface. If there is no plant, all the sunlight hits the surface. But as the plant is starting to grow, it intercepts sunlight. And you can see here that the amount of sunlight that hits the surface is in that 10% range once the crop height is determined. So there is this sweet spot between those two. However, as the lower leaves of the sunflower start to senesce, there is more light available. And that gives us the opportunity to have some growth of the various legume crops. So here's a graph where we have various legume crops, and the V4 means that legumes were planted at the V4 stage of sunflowers. The red part is the yield of the sunflower, and the white part is the legume. So in that sweet spot, we have no yield reduction between the control, but we have that legume biomass that is produced. So there is this kind of sweet area about that V4 leaf stage. And at the end of the season, what we want is to have some cover on the landscape. As mentioned, I've been involved in a sunflower survey, and I'm going to give you a few highlights. We've done this survey throughout the US, but I'm going to focus on a few of the main points. So in 2019, we are just processing the 2021 data. We had about 84 fields, and the yield was 1,700 pounds per acre roughly. And over time, at least in North Dakota, we have seen a pretty close relationship between the established plants that we counted and the yield. So if you look at the plants per acre, you divide it by 10, that gives you a good estimate on roughly what the yields is going to be. What we did is we went to all the fields and we determined what are the limiting factors. And this is data from quite a few years. So you can see from 2011 to 19, and what I want to focus on is that number 18. That means that 18% of the fields, the researchers determined that plant spacing was a limiting factor. So I showed you already a picture where the gaps are large in the field. So this is real. There is a lot of issues with them. The next one that we found was that diseases was about 70% of the fields. A disease reduced the yield. So if we are looking at a large combination of data from 2006 to 2017, about 1,000 fields, we are going to look at some of the data that was generated from that. We looked at downy mildew, rust, sclerotinia, stock rot, phomopsis. I'm not going to be able to report on everything, but just a few highlights. So here, phomopsis, nearly everywhere. FOMA is a disease that is quite predominantly also in Manitoba. And then we are going to look at the yield. So there is a way to calculate the yield based on the head side and some other multiplication factors. So I can, if you go back to some of the resources, you can get this formula. But the point that I want to make here is, if we look at yields of average factors, so we look here, when there's no yield limiting factor, the yield was 2,169 pounds. But comparing that with plant spacing, and you can see that was highly significant, there was definitely a yield reduction taking place there based on the plant spacing. The next one is disease. So you can see disease also has a big issue. So just wrapping it up, field selection, we have to watch rotation. Hybrid selection is important. Looking at different tillage, reduced tillage probably a good thing to do. Timely planting, weed control, of course, and then monitoring for various pests and diseases. There are two resources that I want to mention. There is a sunflower production guide from North Dakota, and there is one from Manitoba. So with that, I will close for an opportunity for some questions, if you have any.
Perfect. Thanks, Hans. There is one question that came up, and it says, is there or have you seen a correlation in potassium deficient soils and the incidence of verticillium wilt in sunflowers?
I'm sorry, I could not quite hear the question.
Oh, let's try that again. Have you seen, is there or have you seen a correlation between potassium deficient soils and the incidence of verticillium wilt in sunflowers?
So you're talking about verticillium, and the problem with verticillium is that it is very difficult to really diagnose. So we don't have really good data on verticillium. We have found in our surveying, and we have sometimes a plant pathologist with us, that just looking at the field, it is difficult to diagnose in the field. So it can be diagnosed in the lab. We have not looked at any really correlation, so I can't answer that question, but I know it is very difficult to diagnose.
Okay, good. Yeah, that's the only question that we have popping up right now. I'm going to ask one because I actually grew sunflowers for the first time since I was a little kid this year. So I'm going to throw this one out there. Maybe it might give somebody else an opportunity to ask a few questions as well. Have you ever seen any correlation with plant population and plant height in sunflowers in a solid seeded situation, so an oil seed sunflower?
Yeah, so plant population and plant height. So as you imagine, there is of course a hybrid dominant factor in the general plant height. If you put plants closer together, we tend to see that the plants are getting a little taller because there is a little bit internal competition with one another. The interesting thing about sunflower is, if you have two seeds that are planted, by chance next to one another, they will compete, and there is one that's going to be dominant, and that one is going to be outgrowing the one that's very close. So there is a very strong relationship between how close plants are together and what the final crop height is going to be between two plants next to one another. If they are nicely distributed with solid seeded, the plants will be slightly taller than when you have row spacing.
Perfect. Thank you for the answer. Well, with that, we're going to wrap up this session here, and we're going to roll in. Thank you, Hans, for the great presentation. And